Imagine space as a stretched fabric. A wormhole is like folding that fabric and connecting two distant points with a tunnel. It's a shortcut through space-time, hypothetically allowing instant travel across light years. Wormholes were first proposed in 1935 by Einstein and Rosen. They suggested that black holes might be connected to white holes, forming what we now call Einstein-Rosen bridges, shortcuts between different parts of the universe. The problem? Wormholes collapse too quickly. Without exotic matter to keep them open, their tunnels pinch shut before anything can pass through. The dream of traversing one remains just that, for now. To stabilize a wormhole, we need exotic matter, stuff with negative energy density. While theoretical, it hasn't been found or created in usable amounts, but quantum effects suggest it might not be impossible. If one end of a wormhole is accelerated near light speed and returned, time would move differently at each mouth. Step through, and you could emerge in the past or future, making wormholes potential time machines. Time travel raises paradoxes. What if you stop your own grandparents from meeting? Known as the grandfather paradox, it's one of many puzzles that make physicists skeptical of time travel's plausibility. Light speed is the cosmic speed limit. Nothing with mass can break it. But bending space-time, rather than traveling through it, might be a loophole in that rule. In 1994, physicist Miguel Alcubierre proposed a warp drive. It contracts space in front of a ship and expands it behind. The ship itself doesn't move. Space does. Technically, it could exceed light speed this way. Alcubierre's idea needs vast amounts of negative energy. We're talking quantities far beyond anything achievable with known technology. Plus, controlling a warp bubble without killing the occupants is another unsolved problem. FTL travel could break causality, sending information back in time. This challenges one of the universe's most fundamental principles, cause and effect. Quantum entanglement links particles instantly, regardless of distance. Einstein called it spooky action at a distance, but it's not FTL communication, just correlated outcomes when measured. Though entangled particles respond instantly, the no-signaling theorem says no usable information travels faster than light. Entanglement is weird, but it doesn't break the light speed rule. Solutions to Einstein's equations allow closed timelike curves, paths that loop back in time. If real, they'd let an object return to its own past. But again, we face paradoxes and stability issues. Get near a black hole and time slows dramatically. Astronauts orbiting a massive black hole could return to find centuries have passed on Earth. This is time travel to the future, via gravity. If one twin travels near light speed and returns, they'll be younger than the twin who stayed on Earth. This time dilation is real, confirmed by experiments with fast-moving particles and atomic clocks. Physicist Frank Tipler proposed massive rotating cylinders could twist space-time into loops, allowing time travel, but it requires infinite length and density. Not exactly buildable tech. If traversable wormholes exist, a ship could enter one mouth and exit light years away. It'd be like walking through a door instead of taking a long journey across space. Some theories suggest wormholes might link different universes, not just distant parts of ours. Traveling through one could mean entering a parallel reality, not just another place. Stephen Hawking proposed that the laws of physics prevent time travel. According to his chronology protection, quantum effects would destroy any time machine before it could form. In chaotic systems, like weather, small changes can have huge effects. In time travel, a tiny action in the past might rewrite the future. This concept, known as the butterfly effect, fuels time travel fiction. From Back to the Future to Interstellar, Movies explore time travel's wonders and dangers. While science fiction bends the rules, it often reflects real scientific questions. Einstein showed that time isn't fixed, it's relative, depending on speed and gravity. This laid the groundwork for real-time dilation and speculative concepts like wormholes and warp drives. Hypothetical cosmic strings, remnants from the early universe, could warp spacetime enough to enable time travel or FTL shortcuts, but they remain purely theoretical. Quantum theory allows fleeting violations of energy rules, like negative energy blips. These might be harnessed for warp drives or wormholes, but we don't yet know how. If you traveled back in time and prevented your grandparents from meeting, you wouldn't exist to travel back. This loop of contradiction illustrates why time travel is so tricky. This principle suggests the universe prevents paradoxes. Any actions you take in the past were always part of history. You can't change it, you fulfill it. Some physicists believe time is a dimension like space. The past, present, and future all exist simultaneously. We just experience them in sequence. Theories of quantum gravity, like string theory, suggest wormholes might naturally form at tiny scales. These quantum wormholes are far too small for travel, but offer clues to unifying physics. With current tech, no. Wormhole construction would need control of gravity, exotic matter, and massive energy. But it's a goal for future civilizations or advanced aliens. Even if you could enter a wormhole, tidal forces and radiation might destroy you. Traversing one safely requires stabilizing it, something we don't know how to do yet. Stories like Looper and Tenet explore paradoxes with creativity. What if your future self affects your present actions? Fiction often explores what science cannot yet achieve. Some theories propose each change in the past spawns a new timeline. You don't alter your own history, you create a branch. It's a popular fix for paradoxes in science fiction. Some quantum interpretations hint at time travel via quantum tunneling or backward-in-time particles, but these ideas remain speculative and unproven. If information falls into a black hole, is it lost? Quantum mechanics says no, information must be preserved. Resolving this paradox may reveal secrets about time and space. No wormholes have been found. They're predictions from equations, not observations. But physicists search the skies for gravitational clues that might signal their existence. Possibly. According to special relativity, FTL movement could mean arriving before you leave, from another perspective. That's why many scientists link FTL and time travel. Wormholes, warp drives, and time travel aren't just sci-fi, they're grounded in real equations. But right now, they remain speculative. Inspiring, but not yet practical. Time is relative. Gravity bends space. Black holes slow time. These effects are proven. But building wormholes or traveling back in time, still firmly in theory. The quest for faster-than-light travel and time travel pushes physics to its limits. Even if we never build a time machine, studying these ideas helps us understand the universe better. From cave paintings to rockets, humans are driven to explore. Whether we ever conquer time or space, we'll keep asking the big questions and imagining the answers. If exploring the mysteries of time, space, and the universe sparks your curiosity, hit that like button and subscribe, because we're just getting started on this cosmic journey.